get into what is case 1 of an arithmetic sequence, right? And I'm going to look at sequences in series. I'm talking now about case 1, and case 1 specifically for an arithmetic sequence. Now, what is a case 1 sequence? Well, a case 1 sequence is a given sequence. Now, in order for a sequence to be considered given, we need 3 terms, right? So I'm going to put that out there, is we need 3 terms. Okay. And then what are the types of questions that you use? Questions that we will get, for example, is determine the position of a term, determine the value of a specific term, and you should be making notes, engrave the neural pattern, right? Determine the value of a specific term, determine the position of a specific term. In general, you generally get 3 terms, and so forth. And how do you solve? You solve these questions by direct application of the formula. And which formula? Direct application of Tn equals A plus n minus 1 multiplied by D. And that's how you solve case 1 questions. Let's recap. It is a given sequence, right? You can generally get things like determine the specific position, determine the specific term, determine the difference, and so forth. And you solve this through directly applying the formula and testing the sequence as well. And so that's how we get it in general. So let's look at this. There's an example. First example. Well, the sequence is given. How do I know it's given? I can see that I've got 7, 9, 11, 13. What type of sequence is this? Well, if you go from 7 to 9, you are adding 2. And from 9 till 11, you are adding 2. And from 11 until 13, you are adding 2. So immediately you can say, Imad, do you know what? This here is an arithmetic progression. Right? It is an arithmetic sequence. Why? It's got a constant difference of 2. To move from the one term to the other term, I just add 2. So you can say is that A for the sequence is equal to what? It's equal to 7 because that's the first term. D for the sequence is equal to positive 2. Okay, just take a moment, understand that, pause if you must pause, and just double check where I'm getting the A and the D from. First term and also the difference. Okay, before we answer question 1.1.1, let's add a question there. Determine the general term of the sequence. Well, the general term of the sequence is going to be Tn equals A plus n minus 1 multiplied by D. And then I can tell you, well, I need to make it specific. So I'm going to say Tn is equal to 7 plus n minus 1 multiplied by 2. And that's going to be the general term of my sequence. Right? This is what we call the nth term formula, or the general formula. In other words, the term value for the term being in position n. Okay, determine the 32nd term. Do you notice that? That's asking you for position. So you're going to say that T32 is equal to 7 plus 32 minus 1. Ooh, great, you spotted that mistake. 32 minus 1 multiplied by 2. And let's simplify that. That is 7. 32 minus 1 is 31. 31 times 2 is going to be 62. Right. And that gives me 69. That answers our first question, 1.1.1 over there. I'm not going to do 1.1.2 because we will cover this question when we do sum formulae in terms of determining what the value of a particular series is. Remember, when we go back to our first video, a series happens to be just the sum or adding up all the terms in a sequence. Okay, and I'm also going to leave out this one over here. And 1.1.5, we've already answered that over here. Okay, so I can say that this thing over here is 1.1.2. Right. So now let us look at one more question. Let's look at the specific question 1.1.3 because that's the one that we haven't done. 1.1.3. Which term of this sequence is 103? Now remember, they're asking you which term equates to 103. So this over here is going to be a term value. Okay. Ooh. That over there is a term value. In other words, Tn is going to equal that. So what I do is I'm going to take my general formula and I'm going to insert it in the Tn position because it's actually the value of the term. So now I say 103 is equal to 7 plus n minus 1 multiplied by 2. And I can simplify this. I can say now, if I solve this, I'm going to subtract 7 from both sides, and I'm going to get a 96 on this side, is equal to 2n minus 2. And then I'm going to add 2 to both sides, and I'm going to get 98 is equal to 2n, because I got rid of this minus 2 by adding 2 on both sides. And then I'm going to get rid of that 2 by dividing both sides by 2. And then I'm going to get the following 90, that's 40, 45 plus 4 is going to be 49. Therefore, n equals 49. In other words, T49 is equal to 103. And I'm just going to put there, and T49 is equal to 103. I think that is fairly simple. Just make sure you practice, go back to it. And remember, this is just one example. We're going to get through an entire revision set of questions like there is in trigonometry and Euclidean geometry, and hopefully that will help a lot more. And so this is a case 1 example. Case 1 is where the sequence is given, and the only thing you need to do is you just need to use the formula. Questions in case 1 ask you what exactly is A, what is D, and then what is this term, which term adds up to this, determine the general formula. So this is 1.1.5 over here, and this is 1.1.2, and this is 1.1.3. We'll do the other two